Hey guys, Profi Hughes here. I'm not sure if you ever wondered how they come up with formulas and various mathematical applications and such. Um, but this is kind of what I do to develop formulas. There's a great video by Presh Talwalkar on a circle that they kind of flip the edge of the circle over and it makes contact along the diameter. And I'll go ahead and link the video down below. Do go out to Presh Talwalkar's site. The guy's amazing. Go ahead and subscribe, share, and like all of his stuff. He really has it going on. But what I've done is I'll give you kind of a step-by-step of how I figured out a general formula to solve that problem just by plugging numbers in. So we're going to go ahead and have a presentation. I'll start from the problem itself, and I'll go ahead and have you look at the video to see how it's solved, and then I'll show you the step-by-step instructions that I used to get to the simplified way to do this. Algebra does mean the simplification, and historically this is what algebra is for. I know you say, oh, when am I ever going to use that? You know, and when are you ever going to fold a circle over and worry about that either? But for professor folks like me and engineer folks like me and scientific folks like me and folks out there building bridges and dams and whatnot, this is cool stuff. So anyway, sit back, enjoy the ride, and we'll talk again soon. Let's do this. So how do you go about making a formula for a geometric figure or other application? First, you have to define the problem and its solution. So go watch this video. You can go ahead and it's down in the description box.
Mind your decisions. I'm Presh Talwalkar. Start with a semicircle. From the upper right corner, carefully fold a circular segment until it just touches the diameter, and divides the diameter into lengths of 4 and 2. The question is, what is the length of the folded line? All right. Well, you watch the video. So next, create a mass reproduction of all the steps in the solution. Finally, use algebraic techniques to simplify. Of course, algebra means the simplification. It comes to us from Arabic. So having watched the video at this point, how did the solution look? What were the steps? Can they be expressed mathematically? Okay, so you were given a circle, or actually a demicircle, half circle, and he had a diameter written in there, and essentially you had the circle folded over, which I won't do here. You can go ahead and watch the video for that. And he had a tangent, and he wound up finding the center of that diameter, which gives us 2 radii. All right. So what he wound up doing is he drew a line this way, and all we had to do now is just solve for a bunch of right triangles using Pythagoras' theory. He used a different name. He used, I believe, the Chinese inventor. That is to say, the Romans have a old proverb that said, damn those who've come up with their ideas before us. So we don't really know if Pythagoras figured it out from Gogu. Apparently, since Gogu's name is on it earlier in the historical record, they now have decided to give credit to him. I tend to call it Pythagoras because he's in the Western culture. So to each his own. Bottom line, you have essentially the radius minus the tangent. Okay, you notice that, and that gave you the number 1 in his example. Now, I'm not going to use specifics from now on. And essentially you had to add that to the other leg squared, which turned out to be the radius. And square rooting that gives you the answer to that leg. Now, of course, the leg was half of what we need in order to use the other. Well, let's go ahead and square it first. And we're going to subtract that from what essentially becomes the hypotenuse, which is the radius of that second triangle we're trying to solve, which will give us our length. Alrighty, so square rooting that response gives us that second leg that we're looking for. Okay, the first leg is that whole jumble in the bracket squared. The hypotenuse is r squared, and of course we have to square root it to get that
second leg. Once you get that second leg, you multiply by 2. Okay, now if you followed along with the video, you'll notice that we have repeated all of the steps. So first we had to find the difference between r and t. Then we went ahead and squared that value to square the other leg, which square rooted gave us our hypotenuse we were looking for, divided by 2. Okay, then we had to take the radius squared, subtract that other leg, and then square root it in order to get our half length multiplied by 2. Gives us the answer. Ta-da! Real quick before we begin, I'm going to use some expanding here. And we know, for example, this is false. You can't have a squared minus b squared equaling a minus b squared. Okay, don't plug in the number 1 because that always seems to give weird results. But call A 2 and call B 3. Go ahead and do it for yourself and find out why it doesn't work. Okay, so let's go back to our formula. It's actually kind of pretty the way it is, and it would be functional, but we can get it a little better than that. So it does say the length that we're looking for is 2 times the square root of the radius minus all of the square root of r squared plus the quantity r minus t squared over 2 squared. That's a big pain. So let's go ahead and start tackling things. So what I'm going to do next is I'm going to go ahead and we're going to expand that r minus t squared. It is what we call, it's called a perfect square. Okay, so essentially that forms r squared minus 2rt plus t squared, and that's what we've just done here. So now you notice we have common r squareds, so we're going to go ahead and clump those together. Alrighty, and then our next step is to go ahead and square that. So that's going to leave us with 2r squared minus 2rt plus t squared over 4. Okay, so obviously 2 squared is 4. And then we have to, since we're going to subtract, we have to equalize the denominator. That comes out to 4r squared minus the quantity 2r squared minus 2rt plus t squared over 4. Now, what we're going to do is we're going to go ahead and from algebra, that whole square root fraction can also be the square root of the numerator divided by the square root of the denominator, and that's what I'm going to do here. I'm going to go ahead and square root the denominator, and that will cause the 2 out front to go away, and poof, there we go. So we're left with our square root of 4r squared minus 2r squared minus 2rt plus t squared. Now, we're going to go ahead and remove the parentheses, and that just means that all the signs in the parentheses are going to flip. So negatives go positive, positive go negative. So boom, there we go. So now we have 4r squared minus 2r squared plus 2rt minus t squared. And what happens here is we have our r squared terms. So essentially the coefficients 4 and negative 2. We'll go ahead and add those together, and we're going to come out with a final length equals the square root of 2r squared plus 2rt minus t squared. And again, r is the radius, t is the tangent. Okay, so what I did is I just kind of grabbed a compass, just opened it, threw it on graph paper, and I wound up recreating the problem. And then I measured literally. So it turned out that the tangent where that circle touched is 4 millimeters. And that left the rest of that diameter at 41.5. Well, those two together added are 45.5, all right? So that's your diameter. Half of that's your radius, 22.75. And of course, the tangent remains 4. So what we're going to do is we're going to fill all those values in, okay? Your radius and your tangents. And we come up with a pretty darn big number, square root of 1200, 1.125. And when we get that done, our length is approximately, and very close, equal to 34.66. And when I measured it, I'm like, yeah, very good. So quad erat demonstrandum. We're done. Go ahead and like, sub, and share. And I'll leave you with a look at the final formula just so that you can go ahead and repeat it. Do what I did. Just grab a compass, grab a straight edge with a ruler, and work out a couple of these things. It would be very interesting if you went ahead and folded that circle down dead center of the diameter. So you have the radius is equal. Of course, your t becomes 0. Go ahead and solve that one. That's really cool. All right, guys? Adios.